Hi everybody. In this video, are on the fifth video because some verse 5 and 6 were both in a video together. In this video of this playlist, we are solving trig equations. We are under a new set umbrella of directions. They say solve the trig equations in the interval 0 to 360. Because there's no degree symbol, that would really mean radians. So I'm going to fix that. And now it is degrees. There you go. Using the hints provided. I guess I can do both 7 and 8 in this video as long as I can keep it under 10 minutes. And I'm going to show you the calculator question for number 8 for anybody who's interested, even though we're going to do the calculator questions a little bit later on. I'm also going to, like in the first example, I'm going to demo number 7 like I did for number 1, where I'm going to use Desmos to kind of show you what we're doing and why. Desmos, though, is set for radians, essentially. So even though the question wants us to do degrees, I'm going to show you on Desmos with radians, and we'll just bop back and forth. We'll just jump to degrees. It shouldn't be that big of a deal. So here, this is what we call a multiple angle. That's where the x or the theta inside has something with it. It's not just x. It could be x over 2, x plus 2, inside a parenthesis, 2 times x, anything like that, okay? X minus 2 plus 2 divided by 2 times 2, whatever, right? So I'm going to get sine of that thing alone first by adding root 3 over 2 to the other side. So then I have sine of 2x is equal to positive root 3 over 2. And now you ask yourself the golden question. The sine of what angle or angles will equal radical 3 over 2? So again, don't forget this is on the interval 0 to 360. So that means we want our degrees and answers. In degrees. Root 3 over 2 is up a lot, so I'm looking for the answers up here. Now, if it were radians, you're looking at pi over 3, and you're looking at 2 pi over 3, which I think most people are better at radians at this point. Since it's degrees, we really have not just x, but now it's 2x equals 60 degrees, and 2x equals, that one right there is 120 degrees, because it's also going to be 60 away from 180. Now, even though we're finding only the answers between 0 and 360, because we have the 2x, that's actually going to compress my graph, okay? So it's like we're going double time. So it's like you're playing Mario Kart and you're going around the track, right? You make 2 laps in the time that other people made 1 lap. In 1 lap, right, a normal person passes the rainbow tree at pi over 3 and 2 pi over 3 and seconds, whatever. But because you made it 2 laps, you did it twice as fast, okay? So we're going to get passing both those trees twice in our time, right? And it's not going to be at 60 degrees and 120 degrees. It's going to be quicker in order for us to be able to do this, right? So imagine this is your lap going around Mario Kart, la, 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 la. And normally it takes you 360 degrees to get all the way around. So normally you hit that first rainbow tree at 60 degrees and the other rainbow tree at 120 degrees. Then, if you took a second lap in that much time, how far apart were the trees? Well, they were 360 degrees apart. 360 degrees apart. And you managed to do 2 laps in that much time. That's what that 2 is telling you. I can't believe I'm doing a Mario Kart. I never did this, so if this works, we're going to be doing Mario Kart analogies on this forever. So now I'm going to divide everything by 2, because if you were able to get these 2 laps done in a lot of time, then you had to have done them much faster. So I'm going to divide everything by 2. So that means you hit the first tree at 30 degrees. If you want to think of it as minutes or something, seconds, whatever. And now that would mean it doesn't take you a full 360 minutes to get back to that same tree. Divide by 2, it's going to take you only 180 to get back to that tree. And then that second tree after you divide by 2, so we divide by 2, divide by 2. Instead of it being at 120, it's going to be at 60 plus 180. Okay, so now what are these answers? If I got to get all my answers between 0 and 360. So here I get 30. If I add 180, that's 210. If I add 180 again, that's 390, but that's too big. Here, 60, add 180, that's 240. And if I add 180 again, 240, 340, 440, 420, that's too big. So these 4, 1, 2, 3, 4 are my only answers. So what are those answers? So remember, you went around twice in the time someone went around once. So your answers are 30, 60, I'm putting them in order, 210, and 240. And there you go. You got 4 times you passed some there's 2 rainbow trees on the track. You passed those rainbow tree twice for each of them because you did 2 laps and the time it took everybody else to do 1. That 2 was your frequency, how many times you're able to get around in that much time. Now, what does that look like on the graph? I'm glad you asked. Let's go look at that. So let's shut these off first. And okay. So here is Desmos. So on Desmos right now, my green line is 0 and my purple line is 2 pi, which is 360, okay? Because my Desmos is set like that. So 0 and 2 pi, that's my 1 lap. Now, normal person driving their sine Mario Kart around, that's their way going around the lap. They start at the starting point, they zip, zap, whatever, and they come back around and they get back to the starting line. Then you were able to do a second lap though, okay? Now, where are the rainbow trees located? Root 3 over 2. So everyone else between green and purple, they only hit that rainbow tree site on the side at pi over 3 and 2 pi over 3. Now, because you had a B value increased, your B value was 2. That means you went around and saw the blue rainbow tree. You saw that tree twice. The first one, you saw it when you were at pi over 6. Well, what's that? 30 degrees. And 7 pi over 6, that's 210 degrees. And then the second tree, you saw it at pi over 3, which is 60 degrees. And then you saw it at 4 pi over 3, which is 240 degrees. So there you have it. You saw it more. If the B value, I don't mean to be going crazy, sorry. The B value were to increase more, right? Then somebody might have gone around 3 times, 4 times, 5 times, whatever, and they would get more answers because you can compress it versus you could stretch the whole thing out quite a bit, yada, yada. But we'll elaborate on all of that when we officially really start graphing. So that's where all of this hokey pokey comes from, okay? So that's the end of this one. That was already 7.5 minutes. So I'm going to end this video here because I feel like everyone's attention span is like not quite there. And I'll do the next example in a separate video because it's going to go, I think, a little too long. If you feel smarter and you love it, thumbs it up. If you don't, thumbs it down. Questions, comments, concerns, requests, put it in the comment section. And I will try to make your request a reality. Bye for now.